In this video clip, we'll talk about examples here. There are 3 questions here. The first one is to find out the value for cosine 225 degrees. We need to use the formula previously we have learned before. There are 3 groups of theorem. And here is the first one. The first one is to describe the relationship between the angle alpha in the first quadrant and the third quadrant. So it's between pi plus alpha in quadrant 3 and the original angle alpha. The second group of the theorem is between angle alpha in the first quadrant, which is alpha, and in the fourth quadrant, which is negative alpha, right here. So that's why here we have all negative alpha, is because negative alpha is in the fourth quadrant. Okay, and here pi plus alpha, they are all in the third quadrant. Okay, and then the third group of the theorem will be, of course, between quadrant 1 and the quadrant 2. So that will be this group. Actually, here is between quadrant 4 and quadrant 2. So here is between quadrant 2 and quadrant 1. We use quadrant 4 is because we have a negative alpha plus pi, and then this angle will go to quadrant 2. So basically, we want to study is between 1 and 2. Here there is an angle which is point P with coordinate xy. Okay, so there are 3 groups of the theorems. Now, before we do the example here, we like to emphasize some point right here between quadrant 1 and quadrant 4. Quadrant 1 and 4, sine negative alpha is negative sine alpha. Again, that's because of this. Y is positive y, and another is negative y. Okay, so it appears this negative sign can get out for sine, but for cosine negative alpha, that's equal cosine alpha is because x coordinates are the same, is because this one is defined as cosine alpha and is also as negative cosine negative alpha. Same line. Okay, x That's why they are equal. For tangent alpha, it looks like this negative sign can get out of tangent, which is similar to sine. So you may remember these three formulas in this way. Except cosine negative alpha is cosine alpha. The other two negative signs can get out of the trigonometric functions. Simple. Okay. Now, with the things in your mind, we may do the first example. First example is again that's cosine 225 degrees, which can be written as 180 plus 40. We know this angle cosine 45 is in the first quadrant, and the 225 is in the third quadrant. So this basically describes the relationship between quadrant 1 and quadrant 3. And then we know in quadrant 1, x coordinate cosine 45, x coordinate is positive, but cosine 225, x coordinate is negative. We know cosine 45 degrees is radical 2 over 2. Then for an angle in quadrant 3, you should put negative in front of it. That's basically the formula we used. Was which one? Was the one right here, between quadrant 1 cosine alpha and the quadrant 3 pi plus alpha. That's the formula we used for the previous example. Now let's look at the second example. The second example right here is sine 11 pi over 3. Remember, 11 pi over 3 can be written as in this way, because 4 pi equals 3 times 4 pi over 3. If you cancel 3, you get 4 pi. And then you know minus pi over 3 is actually 1 pi over 3. 3 times 4 is 12 minus 1, so you have 11 pi. Then over 3, this will be the angle right here. Now, since 4 pi correspond to 2 times 360 degrees, so then negative pi over 3 and 11 pi over 3, they are co-terminal angles. Co-terminal angles. And then they will have the same trigonometric function value. They are equal. Okay, previously we said sine negative pi over 3, this negative sign can get out. Can get out. And then that was my formula. And then we know sine pi over 3 has the value radical 3 over 2. If you put negative in front of it, because there is a 1 here, that will be the final answer. So that's the second example. Okay. Now let's look at the third example and the fourth example here. Okay. So the third example. The third example is negative 6 pi over 3. We know this negative sign can get out. So that's why we have a negative here. And inside is 16 pi over 3. Recall again, a few minutes ago we said this is because of which formula? It's because of the formula right here. You see, for the negative sign here, for the negative sign here, and then this negative sign gets out. Okay, so that's the formula we did before, Now, we go back, continue on the example 3 here, okay? So, negative sign is out, and then we know 16 pi over 3 is actually equal this one. Why? 4 pi plus 1 pi is 5 pi. Again, you times 3 divided by 3, you still have 5 pi. And then plus pi over 3, that's 1 pi over 3. So 3 times 5 is 15 plus 1 pi is 16 pi over 3. So it goes back here. Goes back here. So we know they're equal. Again, there is a 4 pi here. 4 pi here, then it tells us this angle 16 pi over 3 is the coterminal angle of pi plus pi over 3. That's why you have a sine pi plus pi over 3 equals sine 16 pi over 3. You keep the negative sign. Well, previously we have a formula which is sine pi 3 pi plus alpha equals negative sine pi over 3. Previously we have that. That's the formula we learned before. Okay? It's because again here is 3 pi pi over 3 plus pi, not alpha. Okay, let me erase that. Yeah. Okay, then goes back here, should be pi. Yeah, Sine pi over 3 plus pi is negative sine pi over 3. That's by which formula? By the formula previously between quadrant what? Between quadrant 1 and 3. That was the one. Okay, which one? This one. Okay. Yeah. So sine pi plus alpha equals negative sine alpha. Here alpha in our case was pi over 3. You can replace this alpha with pi over 3. You can replace this alpha with any angle. Okay, so again, go back to continue the example here. And then we know if we put negative sign back, here is negative, here is negative again, you have a negative, negative, it comes to be positive. So that's why when you put negative sine pi plus pi over 3, you have a positive sine pi over 3. And sine pi over 3 is radical 3 over 2. To keep the clip time short, please enjoy doing this one yourself. I'll see you